Good morning. I'm Michael Poultney, the Managing Director of Albion Stone, and we've been asked to do a short presentation for the Stone Digital event detailing Albion Stone's road towards net zero. Albion Stone's journey towards net zero began about 25 years ago. We were a quarrying company running out of Portland stone quarries, and they were all subject to the old 1948 permission with very few environmental controls. We realised when we went to the mineral planners that they were going to want more environmental controls, and basically they were going to want us to switch from quarrying to mining. We had to ensure that the switch from quarrying to mining was financially viable. So together with the Crown Estate, our landlord, we did a financial study. And as you can see, the depth of the overburden, the clay and rubble beds above the actual mine portal here at Stonehills, they're actually quite deep. And it was really this overburden that was a deciding factor in the financial viability. The fuel costs for clearing the overburden are high, but then they're offset by the high capital investment that you need in plant to do the mining. The first big planning application for a mine was at Stonehills, and this was back in 1999. We'd had a planning application for a small trial at Bowers, which was passed, and we'd also trialled new extraction techniques without blasting in the quarries. And it was when we were armed with these new reserves, after getting the planning permission approved at Stonehills in 2001, that we set about a change from quarrying to mining. Now, this change was very painful, but it was a change that other dimension stone quarries in Europe were doing at the same time. And like them, we were all very uncomfortably close to the cutting edge of technology. The mining trial at Bowers began in 2002, and after a few years, we'd dug ourselves a nice tunnel, but the extraction was far too slow. And to be honest, we had to ditch most of the equipment, and we had to then purchase more modern equipment, new equipment that was being developed, expensive Fantinis and drills that you see in the mine today. We had a cost probably around about £2 million, which for a company of our size was quite considerable. We realised through this process that obviously we'd reduced our carbon footprint, and after making such an investment, we wanted to promote our achievements to the industry. We got the Carbon Trust involved, and they did some initial calculations of our carbon footprint, and this was back in 2008. To be honest, we really struggled to get any interest from the construction industry, but we did get some architects and some clients were interested. Jordan's mine is now our main production mine, and it started in September 2008 from the old faces in Jordan's quarry. It now extends about 4 miles underground, under 3 roads, and links right through to the Bowers mine. We linked the Bowers and Jordan's mine underneath the church in 2019, and this had the advantage of shortening the haulage routes. The haulage to the factory site from either the Jordans or the Stonehills mine is only about a mile. And like all British stones, the haulage to the main market, ours is London, is about 150 miles. Stone imported to the UK is likely to have a higher carbon footprint from transportation. If the stone's coming from Europe, it could be 1,000 miles of road travel on a lorry. If it's imported from Asia, although the sea travel has a very low carbon footprint, there are other factors. The quarry and the stone factory were probably going to be quite a long way from the port, and when the container arrives at, say, Felixstowe, it's very unlikely that container is going to go straight to the site. It's probably going to go to a warehouse, and it is fuel that is the enemy of your carbon footprint. Originally, all the electricity was from diesel-powered generators for our mine, but as a next step after switching from quarrying to mining, we decided to install mains power to the mines. We now have substations at both the Bowers and the Jordans mine, and although the cost is about £300,000, it allows us to use renewable energy from the grid to power the mines. Our primary extraction tool is the electrically powered Fantini. Basically, it's a giant chainsaw that cuts slots in the perimeter of the face, and perhaps 1 or 2 in the centre, depending on the geology of that face. It leaves the blocks still attached at the rear. Hydrobags are then inserted into these slots and filled with water. They apply equivalent of about 200 tons of pressure and simply break the back of the blocks. The blocks are then removed from the face with a wheel loader, and the roof is drilled and bolted. Our extraction is a simple operation, and with the exception of the wheel loader, electrically powered. Volvo themselves are actually working on developing electrically powered plant and is currently work in progress. We are also trialling biodiesel, which may be a stopgap until the electrically powered wheel loaders are developed. Blocks are taken outside the mine and then trimmed with a JCB Fantini to check the geological characteristics and to ensure the stones are sound before they go to the factory or an external customer. And that is the entire process. And really, as far as the carbon footprint is concerned, it compares very well with other quarry extractions. For example, aggregates for concrete and clay for bricks. We have a large bank of solar panels on the roof of the factory, and it is our biggest investment on purely environmental improvements. Together with the Crown Estate, we invested about £500,000, and at its maximum, it provides over 30% of the power for the entire factory site. We also collect rainwater from the roof of the factory, which is stored in the large black tanks. And like most UK stone companies, we are continuously recycling over 99% of our water. We're inside the Portland factory now, and this is the first stage of the cutting process, the primary sawing. We've just installed 3 granny rock wire saws, and they replaced the Van Voorden 3-metre circular saw that was installed in 1989. Now, although there was no drop-off in its performance, it was working as well on its final day as it was on the day we installed it. The cut width from the Van Voorden circular saw was about 17mm, and on the wire saws it's about 8mm. Now, this difference in the cut width results in a saving of about 300 cubic metres of block per year. They also use less than 50% of the power and significantly less water. These are the more difficult decisions to have to take. Removing a perfectly functioning saw and replacing it with saws that ostensibly do the same job, but at a cost of about £500,000. The next stage of the factory process is the processing of the slab into a finished stone, and this is sometimes complex, but it's simply a cutting process, either with saws or a mason. There are no energy guzzling operation, there's no heating, there's no curing, there's no mixing of products, and there's no chemicals to protect the stone. Extracting and processing stone is simply a series of cutting operations. Albion produces zero waste from our extraction and factory operations. The mine offcuts are used either for armour stone, typically see defence projects, aggregate production, or required to backfill the mine voids to provide additional stability to the mine pillars. Factory offcuts are first assessed to see if they are suitable for the production of walling stone, and if not, then again aggregate or backfill. Like most British quarries and mines, we have large panels showing the range of typical geological characteristics, our range panels. We have Portland Roach, Portland Whitbed, and Portland Basebed. The Whitbed is actually further subdivided into Grove, Fancy Beach, Australia Patch Reef, and Jordan's Whitbed. Unfortunately, many of the blocks will transverse these subdivisions, and this impacts on our wastage and carbon footprint. Even with these purely aesthetical divisions, many architectural teams will want to try and introduce further controls, again impacting on our wastage and carbon footprint. I really worry sometimes that architectural teams feel they need to reject something just to justify their visit to Portland and to ensure they get what they believe is the best stone for the project. After all, ours is an expensive stone. But they do need to understand the implications of what sometimes appears to be just an arbitrary decision. Is this decision worth the consequence that we will be destroying perfectly good stone to meet this range? You can see here slabs of good stone, but they've just been rejected mainly because of aesthetical reasons. All dimension stone quarries and mines will have geological faults that they will need to work to when they extract the blocks. We are lucky if we achieve 25 to 30% yield from the mine face, and this is allowing for the euro measure of blocks, where we measure the largest cube that you can actually cut from the raw block. We then typically lose around about another 50% through sawing and the selection wastage at the factory. A further increase on that selection could increase that wastage to 60%, meaning only 10% of the potential reserve becomes finished stone. Historically, all sound stone would have been used. It was, after all, a building material, and you can see that on these photographs of Unilever House in London. The selection was purely for practical reasons, perhaps save the cleaner stones for carving. We are considering introducing a new unselected range for the restoration of heritage buildings, but we really fear that the desire to select is now ingrained. We do implore all architectural teams to think very carefully about arbitrary selection. Think about the consequences. All slabs are cut to the thickness and selected to the sizes required for your project. If they are not used on your project, then they will probably be cut for walling or crushed for aggregate. The UK quarries and mines are subject to the strictest planning conditions in the world, and this includes restoration. Now, our sites at Portland are designated as SSSIs, which is a Site of Special Scientific Interest, and the cliffs around Portland are all part of a World Heritage Site. Now, it is that unique flora and fauna from the cliffs that has actually migrated into the quarries even during the actual extraction process. Now, this means we can't plant trees as part of the restoration, and unfortunately, trees are great for your carbon footprint calculations. We could plant trees elsewhere, but we really feel carbon offsetting has had a bad press, and it is something of a last resort. We really feel that each company should be doing what they can do to get as close to carbon neutral with their own operations. Albion Stone's extraction operation is expensive. We, like most, in fact all, British quarries do not produce a cheap stone. We're highly regulated, and most extraction sites work to very demanding modern environmental and safety standards from new planning permissions. To demonstrate that we work to these rigorous standards, we are independently audited by the BSI and certified that we meet the requirements of the ISO 9001 for quality management, ISO 14001 for environmental management, and ISO 45001 for health and safety management. From these, it was a logical step to move forward to the BES 6001, responsible sourcing of construction products. At the time, it looked to be the overarching standard for the construction industry, as it requires companies to carefully control the supply chain management and all environmental and social aspects of their operation, with reporting of yearly results and complete third-party verification. Albion Stone achieved the highest rating, excellent, the only stone company in the world to reach this standard. But despite the obvious benefits of BES 6001, the focus really seems to have shifted to the EPD, the Environmental Product Declaration. As previously mentioned, we worked with the Carbon Trust as early as 2008, and through the work with the 14001 had the information available and verified to produce a document showing our carbon footprint. From here, it was a logical step to produce an EPD. The EPD is a snapshot of the carbon footprint of a company in a particular year, but the calculations are becoming more complex, but hopefully more accurate. Our most recent one is for 2017. COVID has distorted recent figures, but we hope to prepare another for 2022, and it will show a significant reduction on an already low carbon footprint. Our 2017 figures were nearly 60% below the European average for dimension stone. We believe we are still the only British stone company to have an EPD for our stone. We believe the natural stone is obviously the natural choice for any specifier looking for a low carbon cladding, flooring or paving. The alternatives are reconstituted stone or ceramic. They come from similar quarries, but they use cement, which contributes between 4 or 8% of the world's CO2 alone. And there are alternatives to cement in the UK, but these supplies are limited. But the production process for these alternatives involves crushing, mixing, salting, the use of molds, and sometimes firing. All of these are very energy intensive operations. If you choose natural stone, then British stone is the obvious choice. Its extraction is highly regulated. With low transportation distances to the site, it is the natural choice. Albion Stone, however, is really the natural choice if you're looking for a low carbon stone. We have taken the difficult and expensive long-term low carbon decisions, including a switch from quarrying to mining, switch from diesel power to electric power coming from renewable sources, solar panels on the roof of the factory, and we are now reviewing all manufacturing options, removing less efficient, older machines with the very best current technology, and even trialing biodiesel. The consequence of all this investment is that by 2017, we had a carbon footprint 60% less than the European CO2 dimension stone average. With our recent changes and planned improvements, we expect to reduce our carbon footprint by a further 50%. Albion Stone have a commitment to reduce our carbon footprint to as close as possible and practical to net zero by 2025 and this is without using carbon offsetting. Even worse, we are sometimes asked to supply our EPD to projects that the construction team know have not used our stone. This needs to change. If climate change really matters, then it should matter for all products and for all suppliers. Perhaps it's the natural industry's fault. We are a small, fragmented industry compared to the concrete big boys. I think we assumed it was obvious that our stone, British stone, was a natural low-carbon option, simply hewn from Mother Earth and cut. Perhaps even with Albion Stone's extensive efforts to reduce our carbon footprint, we haven't relayed this information to the architectural teams and the general construction industry. Hopefully events like Stone Digital are addressing this issue. Thank you for listening.